discuss and address the sustainability challenges. I think this is one of the very important things that we are talking today. And yes, sustainability is a buzzword today. We are looking forward to sustainability almost in all sphere of our activities, whether we talk about infrastructure, whether we talk about the energy issues, whether we talk about materials, each and everything we like to have the sustainability. Whatever it means, whether we talk about encompassing aspects like economical issues, the social issues, or environmental issues, or depleting different kinds of natural resources, and how do we maintain it, how do we preserve it, how do we make situation durable. Well, there are several definitions, several aspects when you talk about sustainability. And in fact, all the institutions, the academic institutions, the industries, the research and development establishments, all are trying to work on several issues related to sustainability. So on the second day of this interesting webinar, we are going to discuss aspects on challenges, the challenge seekers, the innovators, activists, performers in different aspects of sustainability. And we have with us a number of eminent personalities who are working in this area on different aspects, and they will be talking on several issues. So without wasting much of time, I would like to get into the business directly, and I will introduce the speakers as I will go along. In fact, this evening we have 3 speakers who will be talking first, and then we have 2 panel discussions. So I'm going to be a little strict with the time. So whatever time is assigned to the speakers, I request the speakers to stick to your time, and maybe 1 or 2 minutes before your scheduled time, I will just give you a warning so that you can close your talk accordingly. So first speaker of today's evening is Mr. Sarbojit Rakshit, who did his bachelor's in mechanical engineering from BE College in the year 1997. He is the IBM Master Inventor and is awarded with about 650 US patents in different areas of technologies. He is a member of multiple invention development team of IBM. And as a part of his role related to invention, he reviewed a number of inventions submitted by different IBMers and recommends for next suitable steps for IP protection. He is mentoring, guiding new inventors, and he is also delivering various patent education in different groups with IBM and various other groups. So I welcome Sarbojit to present his views. And again, I request you to stick to your time of 15 minutes assigned to you.
Yeah.
Sarbojit, please.
Thanks a lot, Simanda. And thanks for giving me an opportunity to speak in this forum. And very good evening to all my senior and my juniors who are joining in this call. Okay, so I'm just quickly getting into the presentation. So I have just changed the main topic, but content remains same because of the confidentiality. The topic we cannot discuss, that is topic name, it is mentioned in that document, in the schedule. But I have changed, but it is almost remained same. So moving to the next one, next slide. It is open innovation. So first thing is, it is each and every company we need to continuously innovate so that we can sustain with this current journey. So the point where I'm talking right now, it is open innovation. It is not an innovation, it is a management of innovation. So there are 2 types of innovations are here. One is closed innovation and open innovation. And current days, I'm just telling that it is companies are following open innovation. So before that, it is, let me explain that what is closed innovation. So closed innovation, you can have a look at this funnel that I have just shown over here. So it is in a, so this is the boundary of an organization. This is a capability that beyond that capability cannot, organization cannot go beyond. And these are the all the ideas that any organization is having. Now you can see that if it funnel through and coming to market is very less. It is, there maybe it is hundreds of idea, but if we see that how many ideas are materialized is very less. You can see here. So that's the problem with the closed innovation. And that's what we need to have open innovation. Open innovation is basically a collaboration. It is the use of power of we. Now you can see in this funnel, the same funnel, but this funnel is exposed. It is from different directions. So it is, you can see that these are external collaborator, alternative markets. Okay, now you can see as it is exposed in all the directions. So you can see that it is from different directions that ideas are getting materialized. Okay, so now if you compare with the previous diagram, it is in one side a set of ideas are generated, in another side a limited ideas are getting into market, and that's what that number of it is hit ratio is basically less over here. But if you come to open innovation, this is the open innovation. So all the ideas are coming, and when it is coming out from all the direction, you can see number of it is materialization of the ideas are more. So now how it is, what is the model over here? So one is inside out. Inside out is basically it is sharing one company's knowledge to the outside entire world. Outside in means it is getting information from the external domain and adopting the same in the company. And couple, it means join together to find out a new solution. Now think of a situation that how these couplings are done. So it is, you can see that this is a funnel, and funnels is porous. It is connecting to, it is coupled with external bodies, and from there it is research is being done. So now if you have a look at, this is the diagram over here. So you can think about any company, it is XYZ. So this is the company over here, and this company is collaborating with various other bodies in the external world. So who are there? It can be supplier, it can be technology and scientific contributor, it could be, it is any standard bodies, government bodies, it could be, it is any it is institute, it is the universities, a lot of things are there. Also crowdsourcing is also there. You can see that here one company is participating or collaborating with various bodies of the external world. So now they are thinking together to find out that what type of new innovation can be done. Okay, so moving here, so these are the different ways we can have, say it is open innovation, so it is joint research. For example, it is IBM has a, it is MAU signed with BE College, it is IIEST. So probably in the last month, I forgot that time, I was also there. And so IBM will be providing training, some resource access to the BE College student or IIST student. So here it will start with, it is joint research, it is corporate venturing. Crowdsourcing is also very important. For example, it is, I have some example, I'll go in more in detail, but crowdsourcing is basically, it is IBM or any other company, they can, it is share one idea that if we can, that entire public can share their ideas in this area. For example, it is how COVID, it is contact tracing can be done with the blockchain. So this was the challenge IBM has created. Now this crowdsourcing, that it is from the entire world that people are participated and they have provided their ideas. Joint GTM, it is go to market. It is as a team, say it is a set of two companies. What they can think, it is they can work together and go to market together. It means that one company might, it is do research, another company might implement, or can perform joint research and it is work with the, it is create product and go to market together. So there are various things are there. You can see that it is grand challenges. It is IP licensing out. So it is IP licensing out means it is, you can see that IBM is having a lot of patents. So IBM is having a portal where that all the, it is anybody can, if they wants to implement any of the IBM idea and wants to incorporate in their product, they can get the license from IBM. Co-creation, it means as a team, it is a set of, it is not a single entity. So it is two organizations, three organizations can work together to create a new idea. Now, there could be a myth that it is if it is open innovation, then why the IP right will come. So IP right, it is, people might think that it is open innovation means it's free to everybody, or it might think that it is a free IP zone. So anybody can, for example, it is one organization is partnering with few other organization and creating an IP. So this IP is free to everybody. It's not actually. Okay. So here it will be having such a share IP right. So for example, the two organizations are working together to create an IP. So here the thing will be that it is that IP will be shared among that participating parties, those who have invented or worked together. Or they can have, say, it is joint ownership, they can have allocating a license, it is to other team. For example, it is company XYZ, they have created one invention and they are allocating that, giving license to other company so that they can start using that particular invention. So how this open innovation is helpful? So there are, it is, we can say that's closed innovation. It is long back. Okay, now it is open innovation. But you can see that open innovation is not a new concept. It probably exists for a years. For example, you might have seen that it is our grandmothers or mother, what they used to do, they used to share that food recipes with each other. Okay, and they learn from that recipe and think that yes, this could be a new way of making food. So this is also open innovation. It is not keeping with one person and not allowing other people to access that one. So here the thing is, it is allowing other people to access, and obviously that, as I mentioned, that it will be, if it is a joint creation or co-creation, it will be IP right will be along that participating team. Okay, so as a team you can just create ideas. So innovation will be having speedy. For example, so it is somebody, one particular organization may not have any skills in medical science. So if they can collaborate with doctors or team of doctors, so they can also invent something related to healthcare. Maybe they are good at software, but not good at medical science. So if they can work together, they can create some good products related to healthcare. Okay, so it means it creates that it is speed up innovation. It can bring new way of creating. It is new type of inventions. New ideas might come. It will reduce the cost. Okay, and that hit ratio will also get increased. Okay, now I'm giving some example over here. So it is I'm just taking this all this example from, it is public domain. Okay, so it is free to use. So you can see that this is the portal over here. So what are the license patent IBM is having? Okay, if any organization wants to use that patent in their product or services, or to improve or to implement for their customer, they can apply directly to IBM and they can get patenting licensing on that. Okay, so you can see that this is also, you can just have a look at the tech cloud I have just shared some time back. Okay, so here it is IP licensing and out licensing. Okay, so you can see that IBM is allowing this product to access, everybody can access, and once it is everybody can access, they can get the which product patents they want to use in their product, they can find it out. Now think of a situation that it is IBM is collaborating with some other, it is food manufacturing company. Maybe IBM may not have that expertise in food manufacturing, but IBM is partnering with some other food manufacturing to create products related to food related products. Okay, so here this is also open innovation. So it is how IBM is partnering over here. Now say it is IBM and Vodafone they are partnering. Okay, and creating that, it is that all these communications over here. So this is also open innovation culture. It is not keeping the IP with one person or one particular company. It is allowing everybody. It means allowing everybody, means those who wants to participate and contribute. And contribution and participation can be done in various ways. As I mentioned, that it is joint go-to-market, co-creation. All these are part of that. It is participation. Moving to next slide, you can see that it is IBM and Verizon. They have, it is 5G and AI solutions. So this is also another example of, it is open innovation. Leading university participation. So you can see that it is IBM has, it is MAU signed with IIEST, we also know. Okay, so IBM also, it is working with some leading universities on quantum computing research. So these are is public domain information. So IBM is, you know, that it is IBM has a huge contribution in it is landing man on moon. Okay, so IBM is working with NASA for it is next landing in moon, and IBM collaboration with hospital. It is, you know, that IBM oncologist. It is they are working on cancer research. They are it is having collaboration with Apollo Hospital. In Apollo Hospital, the doctors are involved, and the IBM is getting related information, relevant information related to cancer patient. Like that includes it is images, all these, and all these are analyzed in Watson technologies to find out or predict that it is cancer, predict cancer related diseases or tumor related diseases. So here IBM may not have that it is skills, but as it is collaborating, so it is creating it is knowledge corpus, and for I mean suggesting that it is what type of new product can be created related to healthcare. So IBM and Samsung, you are working together, okay, and it is again example of it is open innovation. Next point is IBM has offered free access to all the patent portfolio to combat it is COVID-19. So there are some patents IBM has provided on it is donated to the entire world. Those can be used for fighting COVID-19. So that can be it is contact tracing, could be used for it is something related to pathogen controlling. So all information it is we patents we have that one, and we have provided to free to entire world. So if anybody wants to make product out of that, IBM is allowed them to access that patents. Okay, so also IBM has it is creating some partnership with wearable devices companies to create something on say it is new products to track worker behavior, all this, and to find out workplace safety. Have a look at it is IBM has launched one crowdsource contest for COVID solution. So it is anybody that's who are accessing this site, they can submit their ideas that how to combat or it is control it is COVID-19 pandemic effect. So these all are it is crowdsourced IBM has funded. And now again coming back to the previous slide that I was talking about. So now have a look at this scenario, this diagram. So this is the funnel. Okay, this funnel is coupled with multiple other external bodies. You can see over here, and it is collaborating. All the ideas is it is one company is having, and the participating companies they are having, they are collaborating, and you can find out that it is get the hit ratio of the ideas in getting into market is also getting increased. So it is because of the external participation, they are providing their skills. You can see that ideas are coming out, more the ideas are coming. So this is called open innovation. Now again, I'm going back to the closed innovation part so you can understand the difference.
Sarvajit, I would request you to wind up in a minute.
Yeah, I'll be done in few minutes, a few seconds. So this is it is closed innovation. You can see that no ideas are coming out. It is exposed in one side, and hit ratio is very less. And that's why we need to have open innovation in these current days. So that's what I have. Thanks a lot. Thanks for listening to me.
Thank you very much. Thank you very much. An excellent presentation. You spoke about open innovation, the IP right requirements, and cited few examples how IBM embraced others to have open innovations. Maybe quickly we can have one or two questions before I go to the next speaker. Is there any question? Yes, please. Or I think you need to unmute.
Yes, this is Arup Bhattacharya. I'm speaking. It's a very excellent presentation, Sarvajit. You reminded me of a lot of history in IBM. And just to give a little comment, the whole innovation and products got speeded up post-90s when IBM deliberately decided to open up a variety of activities that used to be trade secrets. That included even some of the things that I had worked on in the past of how to transform from VLSI to ULSI, which was a project IBM accomplished 10 years ahead of the industry. So, just to give you an anecdote, if you look at the number of patents that came out post 2000, it became 3 times than what used to be the preceding decades. So this open innovation is extremely critical in the form of bringing all the people on board, and especially on sustainability, where all of us from various disciplines can share in every aspect of it to make this world sustainable. Thank you, Shorvajit. It was an excellent and very appropriate presentation.
Thanks a lot.
Thank you.
Just a minute, just a minute. Before we go for the next speaker, I think actually I must say a few words about the session chair, Professor Shriman Kumar Bhattacharya. Actually, this is for the participants who are not alumni of BE College. Professor Shriman Bhattacharya, he has already mentioned that he is a 1979 batch civil engineering. He is a distinguished alumnus of BE College, and he presently is a senior professor of IIT Kharagpur. He was in CBRI for 5 years and did a lot of very useful work there, and he earned a good name there. And Shriman is a person who actually we talk about civil engineering as a engineering for the civil society. Shriman follows that. He keeps knowledge and track of all the disciplines so as to be a complete engineer. And I do not want to extend too much. I would request Shriman to continue.
Thank you, Susan Samada. Thank you very much for your kind introduction. If there are no questions at this point of time, I'll move on to the next speaker. Our next speaker is Mr. Solomon Jones. Is he here? Mr. Solomon, are you here?
Yeah, I'm here, sir.
Yes, Solomon has joined.
Okay, that's very good. That's very good. Mr. Solomon Jones is a very young graduate. He graduated in the year 2016 from SRM University, and he has worked in the area of nanotechnology, and more so, he has worked extensively in the area of graphene. So today he is going to take us through graphene as a wonder material for India and to make things sustainable. So Mr. Solomon Jones, would you please come forward and present your talk today? And again, I would request you to keep your time strictly within 15 minutes.
Yeah, sure, sir. Thanks a lot for the introduction, sir. So I'll go ahead and share the screen and start with the presentation, sir. Yeah. So, good evening, everyone. So I'm Solomon. I'm the founder and CEO of Terracar Private Limited. So we are a deep science startup based in Coimbatore, Tamil Nadu, working on developing graphene-based additives for different markets. So the intention of this presentation is basically to sensitize people in the society about what graphene can do for enabling a sustainable future. So to begin with, so I'd just like to begin with a question, which in this slide, you can actually see a list of these innovations, which are indispensable part of our day-to-day lives. A common synergy among all of these products that you see on this slide is that all of these materials use carbon materials extensively. Where graphite is basically a very important critical part of this EV batteries, and carbon fiber, which is being extensively used in aerospace materials today, as well as activated carbon, which is used in water purification extensively as of today. But what if we could have one such carbon material in the allotropes of carbon, which can also help in technological development?
Mr. Solomon, can you be a bit louder, please? Your microphone.
Yeah, sir. Hope it's better now. So what if we could have one carbon material that could not just help in the technological advancement, but can also help us achieve the sustainable development goals set by the United Nations? So graphene is one material which can help us achieve that. It is basically the best of both worlds, because as you could see from this slide here, it has a very exquisite mix of properties. ranging from very good electrical as well as thermal properties. This is a material which can also be used as a filler with composites, polymer composites extensively, as well as metals. And this can also be used as an antimicrobial material as well as an anti-corrosion material. So as you could see, the potential implications and use cases that can be built with this simple carbon material is enormous. So this is one material which we can consider as the steel of the 20th century. So although this material is so unique in its own sense, we don't see a lot of this material in the market today. So, and the reason for this has to do with the sophisticated manufacturing process of graphene. So as you could see in this slide, the conventional processes uses a lot of capital intensive and chemical intensive processes, which makes the overall production process unsustainable and also makes the process expensive. To give you a perspective, the global average cost of graphene per kg stands at $200 per kg, which is still expensive for any B2B business buyer. Considering that, if there could be solutions regarding cost reduction in the graphene production, as well as measures taken to improve the production process overall, we can have a material which can resolve many of the challenges that we have in the society today. So talking about what kind of challenges graphene can address, to the right of this slide, you can see the various market opportunities that are possible when we have graphene in scalable volumes. So as you can see, the most important application or the most targeted application as we speak today is the composites market. And in the graphene ecosystem, it's often known as the low hanging fruit because developing graphene based composites is one of the easiest projects in terms of the development timelines. But other than that, the other very interesting application that can be developed with graphene, and which is the need of the hour, is use of graphene in energy storage devices. So graphene has very unique electrical properties which can help develop safer battery chemistries, which is also need of the hour. So basically, other than that, there are other use cases, as you could see here, such as coatings as well as water treatment, where graphene can be an extensive enabler. So to give you a perspective about how big of an opportunity this is globally, according to a 2019 market research by a leading UK-based capital market company, so the total addressable market of graphene-based additive for all the sectors is upwards of $150 billion USD. So considering this opportunity available and the numerous implications that it can provide to sustainability, it is definitely a good opportunity to pursue the production of graphene. So just to give few examples, real life use cases that have been deployed commercially as we speak today, to showcase how graphene can be a good enabler for sustainability. So I have basically split this section of this presentation into 3 use cases where we would be focusing on composites, paints and coatings, as well as energy storage. So to begin with, in the composite sector, so MSI is a very famous Taiwan-based laptop manufacturer, which specifically makes graphic intensive PCs. So for their latest GPUs, they have used a graphene-based backplate, which has 20x better heat dissipation than the conventionally used copper. So copper is basically used in all of these backplates conventionally because of its improved thermal property. But because of its exquisite mix of electrical as well as thermal as well as mechanical properties, when a graphene-based backplate is adopted for this GPU, we have witnessed a 26 jump in the heat dissipation value, as well as the mechanical strength of this black plate has also been improvised. So, and this is a GPU which is currently available in the mass market today. So other than that, for simple composite applications such as HDPE based liners which are used in oceanic farming, when a small proportion of graphene of the order of 0.58% or 1% is added, the ultimate tensile strength and the abrasion loss can be brought down severely. And what this implies is the overall shelf life of the composite material can be improved when a small fraction of graphene is reduced, when a small fraction of graphene is used. So this basically ensures that the amount of energy that goes into the production of plastic can be reduced extensively, thereby reducing the overall carbon footprint that goes into the manufacturing by improving the shelf life of these products. So other than that, some of the other very interesting use cases as we speak today is basically a company called Charge ASAP based in US has developed a graphene based composite cells, which is basically using graphene composite cell developed by Panasonic, which basically can charge up to 5 electronic devices at the same time. And not just that, it promises uh, fast charging features at less than 35 minutes. So 80% of this power bank can be charged in less than 30 minutes. And not just that, when compared to the conventional lithium ion batteries, it has 4x better cycle life, meaning it can be used for about 5 years. And because of the enhanced thermal properties of graphene, it that the temperature of this overall energy storage device is also regulated, basically making it a lot more safer than the conventional lithium based energy storage options. And not just that, there is another company called Apparel Graphene Materials based in the UK, which has developed a graphene-based anti-corrosion primer. So this use case is demonstrating how graphene can be useful for the paints and coating industry. So one of the customer has quoted that this is by far the most effective anti-corrosion solution that they have ever witnessed, which basically reflected in the numbers. The nearest competition can deliver 5x inferior results only when compared to this solution. And more than that, the overall coating performance has been improved by more than 4 times of the predecessor's product. So when a small proportion of this graphene is added, such a meaningful improvement in mechanical, electrical, as well as anti-corrosion property can be realized. And not just the and taking overlooking the commercial aspect, there are other very interesting elements to adopting graphene. So because of the improvement in service life, we can achieve 12 and 13 of the sustainable development goals, which are responsible consumption and production, as well as climate action. So by developing graphene based composites, we can basically improve the recycling ability of the polymers, and also reduce the overall carbon footprint in the polymer industry, which is one of the most polluting industries. And not just in polymers, graphene can be extensively used with cements, metals, as well as other for manufacturing other composite systems with enhanced service life, which basically ensures that we also would be helpful in othering to the sustainable development goal 11, which is sustainable cities and communities. So in addition to that, because of graphene's ability to provide solar cells with better efficiency, as well as energy storage capabilities that can be possible with graphene, we can also achieve sustainable development goal 7. So in regard to the impact potential, there are 4 sustainable development goals that we can achieve when the graphene is deployed at scale for all of these use cases. So talking about the third segment of the presentation, which will be about why and how graphene is valuable for India as a country. So talking about that, I talk about 2 of the segments with which we have been experimenting with. So we as a company have deployed resources and developed use cases in 2 of the segments, and we'll try to emphasize on why these segments seem very important for us as we speak. So the market size for lithium ion chemistry, which is predominantly used in the electric vehicle ecosystem, stands at 5.29 gigawatt hour, which is a very commendable number by any standard. When compared to the global projects deployed using lithium ion chemistry, India would have a commendable market share in the next 5 years. Although India has such a market size, we have very few companies which have operational lithium ion cell manufacturing units. So just to give you a perspective, there are 2 companies, Exide and Amaron, which have signed JVs and have a very small pilot units that are manufacturing cells as we speak today. And then there is one Chennai-based company called Lee Energy, which is also having a kilowatt-hour scale production of lithium-ion based cells. So basically, we have only 3 lithium-ion manufacturing facilities, which are in pilot scale as we speak today. And to cater to this demand, we'll have to ramp up the production to several orders of magnitude. And to ramp up that, we still don't have the supply chain maturity to cater to such a demand. So basically, considering this, we would be needing a lot of advanced material based raw material suppliers who can cater to the specific demand to the growing lithium ion market here in India. And more than that, if we could work, as the previous speaker mentioned about open innovation, if the supply chain companies can work closely with the lithium ion companies and basically ensured that the manufacturing lines can be more modular so that new battery chemistries can be accommodated with the production lines. India could be a global leader in the energy storage production because there is already disruption in the lithium ion chemistry. So every day as we speak, there are new battery chemistries that are discovered. However, there are very limited opportunities that are explored along these lines here in India. So if we can, so basically India has a last mover advantage without additionally investing capex in new R&D. If they can work closely with the supply chain partners, new battery chemistries can be developed with in line with the suppliers requirements, basically ensuring that India leads the energy storage race when compared to the other global competitors that we have here in the world today. So these are few of the observations that we have had in the energy storage sector. So other than that, one very important industry as we speak today is the packaging industry, because the solid waste management has been a very big concern for us as a country. But the interesting part here to note is that as per reports from last year, the per capita packaging consumption of India is still 10 times lower than USA, and we still as a country have challenges with plastic waste disposal. And the growing trend in storing of edible foods basically ensures that the flexible packaging segment would be witnessing a robust growth in the upcoming years, which means that we should have a more robust end-to-end integration of the supply chain, wherein the consumer and as well as the manufacturer would ensure that the metal would be recycled. But the challenge is that in most of the food packaging products, due to the requirement of barrier properties, we use aluminum foil, or we also use certain kind of polymer based coatings, which makes the recycling all the more difficult. So considering that the per capita packaging consumption of India as a country is going to shoot up in the upcoming years, if we can design packaging solutions keeping recycling as a very important constituent in mind, we can basically tackle packaging or polymer based waste very well overall when compared to the advanced countries that we have around. So if not, it's going to be a lot more challenging, considering that we already have some issues with the solid waste management. And as you could see to the pie chart to the left, the flexible packaging segment holds the maximum market share when looking at all the packaging materials used in India. So considering that, if we can make the flexible packaging products little more conducive to recycling, it will help all the more to basically streamline the production as well as disposal of waste polymers. So considering
Solomon, may I request you to wind up in a minute?
Yeah. So considering that at Terracarb, what we have done is basically developed two use cases wherein we have developed graphene-based electrode materials which have 20% better specific capacitance as well as more than 1 million cycle lives. When compared to the global competitors, this is at least 20% better. So this is a TRL 5 level validation. And not just that, we have also developed graphene-based additives which can be used to improve the barrier properties of the packaging system as such, which is also one of the first in the world. So we have got TRL level 6 validation for both of these use cases. So considering that, we strongly believe that the use cases that we have built so far would be disruptive for improving the sustainability aspect of our country as a whole. And the work that we are doing currently would not be possible without the partners and the ecosystem that we have right now. So I thank all the people who took time to organize this meeting. I'll be happy to take more questions along these lines. Yeah, thank you.
Thank you, Mr. Solomon. Solomon actually is the founder and CEO of TerraCurve Private Limited. I think it's your startup, right, Mr.
Yes.
Solomon? That's great. I just have one quick question. I mean, it's good that graphene is required to be used on many sectors as a material. But are we producing any graphene in the country as yet?
Yes, sir. We have more than 20 companies manufacturing graphene as we speak today, sir.
Okay, that's good. Any question from the audience? Yes, Arunda, please go ahead.
Actually, again, my great compliment to
Arunda, 1 second, we'll come back. Let Arunda ask the question and then we'll come back to you.
Again, my real compliment to Solomon for championing graphene. I have brought this in many ways to the interest of scientists and technologists and environmentalists that just like what we created a silicon age in the last 50, 60 years, I foresee what the graphene age for next 100 years. Graphene is the miracle material, and graphene with 2D materials along with India could really be in the forefront of the world, developing a whole variety of not only 2D electronics, but also all these various things that Solomon is talking about. We have an enormous opportunity to catch, and if I had my drugger, I would put a lot of focus in energy storage technology development in India to displace lithium ion, because lithium ion I do not see a long-term possibility. It has a serious sustainability impacts, and it's not available easily all over the world. The world will do a great service to pushing the graphene, and particularly I'm gratified the young person like Solomon is flying this banner. I am tremendously hopeful that India will lead this area of not only electronics, but sustainable packaging and all kinds of other application solutions through graphene-based and 2D-based materials. Thank you, Solomon.
Thank you. Thank you. Yeah, Ochunda, please go ahead and ask your question.
I must thank Solomon for starting a business. That is the most important thing, which is not much taken up by our engineers and technical people. Thank you. But the question is, you should go for backward integration of manufacturing graphene, one. And my second question is, will graphene replace lithium in the battery? Lithium is in short supply. Done.
Not really, sir. Not really, sir. So basically, graphene can be used in line with lithium-ion battery to improve the overall cycle characteristics of the battery, but it can never go to an extent where it can actually replace lithium. So graphene can be an enabler for developing other battery chemistries. So indirectly, it can actually help with the lithium shortage, but it cannot be directly used to replace lithium ion.
Will it reduce the requirement of lithium in a battery by application of graphene?
Yes, sir. So in cathodes, it can actually be used to reduce the amount of lithium used in cathode by basically incorporating graphene. It can, to a extent, if I could say in terms of percentage, there can be a 5 to 15% reduction in usage of lithium-based materials in the cathode, but that is what we can achieve, sir. But yeah, if we pursue alternate battery chemistries with graphene, that could be a easier way to tackle the problem of lithium and shortage.
Thank you.
Thank you. Thank you, Mr. Solomon. Thanks for your nice presentation and the explanation.
I think Providya is raising the hand, and
okay,
I'm not sure
Providya,
who is right
let us ask quickly a question. Providya, please go ahead.
Can you hear me?
Yes, yes, sir.
Solomon, my name is Dr. Praveen Yogi, and my question supplements that of Dr. Arup Bhattacharya.
Yes.
And that has to do with the role of graphene in energy storage as applied to the role of renewables, both wind power and solar power, in filling maybe half of the energy gap in India. You know, if you're going to generate 400 gigawatts of extra energy and half of that is intermittent power, then what about the storage?
Yeah.
Is there a well-developed technology now for the use of graphene in energy storage? And is India in a good position to sort of take advantage of that ability compared to, say, a nation like China?
Yeah. So basically, we have a lot of TRL level 4 developments in the energy storage sector. So especially one interesting use case is using zinc, aluminum, and sodium ion based battery chemistries where graphene can be effectively used as an anode. So these are some interesting battery chemistries which are which have shown very robust characteristics, and the supply chain also seems to be very localized. Considering that, if opportunities in the zinc, aluminum, as well as sodium ion based battery chemistries are abundant when graphene can be used as an anode. When in the lithium ion battery, graphene can be used as a complementary material to improve the battery characteristics. But if we pursue these battery chemistries, there are a lot of interesting developments. So even in our country, we have a few interesting startups which are working on TRL level 5 and 6 deployments in this use cases. So in the next 5 years, we would see a lot more interesting use cases where graphene would be an integral part of the electrode in these battery chemistries. Yeah.
Okay, thank you. I think there is a question from Mr. Rai Chaudhary.
Yes, thank you. Thank you, sir. Yes, I would like to know. What is the prospect of graphene in point of care diagnostics. Like there are reports even during this COVID-19 pandemic that it has successful clinical reports for attesting COVID-19 in patients. Like this report from the Western world. So I would just like to know, basically graphene field effect transistor more effectively. What is its prospect in point of care diagnostics? And do you have any plans to go forward in that direction?
Not really, ma'am. We don't have immediate plans to work on electrochemical biosensors using graphene, but there are a few interesting developments that are happening currently. So there is one company called CAS Technologies based in Bangalore, which basically develops graphene grades which are compatible for this application. So maybe they would take up some projects like that in the future. Yeah.
Thank you.
Yeah.
Thank you. I'm sorry, madam, I used Mr. Rai Chaudhary.
No, it doesn't matter, sir. It's okay.
Okay. Well, I think there is a question from Mr. Dev. Please go ahead.
Graphene is a wonder material, as you are talking about, and also you mentioned that it's anti-corrosive, corrosion barrier. Is there any application for lining water mains, water pipelines, mineral water pipelines? At present, it is epoxy is used for lining water pipelines. Whether graphene can be better than epoxy.
Yeah, sir. So basically, there are a few TRL level 7 to 8 demonstration where graphene reinforced epoxy has already showed better anti-corrosion characteristics. So graphene blended epoxy can actually improve the anti-barrier, anti-corrosion properties of metals basically. And there are some products predominantly commercialized based in North America. So this should be very much possible, sir. So because of the enhanced barrier characteristics of graphene, when we blend graphene with epoxy, we can definitely develop a solution where it can be used as an anti-corrosion additive. So it's very much possible. Yeah.
Yes, please.
Shriman?
Yeah, go ahead, please.
Yeah, I would like to add 1 minute comment in answering Professor Roy Chaudhary's question. Graphene is one, as much as I know, is perhaps the best sensor materials for diagnostics. And it's an amazing sensor material, and I believe that incredible scope exists in India, using graphene as a base to develop all kinds of sensor-based electronics.
Yes.
Okay,
Yes,
thank you.
Thank you,
I
sir.
think there is one more question from SP Bhattacharya. Would you like to ask the question?
My question is very simple, that what is the effect of electromagnetics on graphene? How graphene reacts to electromagnetic conditions, whether for suppression or for conduction or susceptibility, how it works? Any idea can you give?
Yeah, so there are some products available in the market where graphene can be used in shielding sensitive electronics from electromagnetic radiation. So basically, it's a material which can basically reflect many of the wavelengths of electromagnetic radiation. So basically, one very interesting use case is that the graphene, when incorporated into conventional paints, can convert the conventional paints into EMS shielding paints, which is one very interesting use case. I hope I answered your question. So
But is it not with some metal mesh that in this paint or anything, whatever the electromagnetics they are doing,
Yeah.
how composite or graphene? Any example do you have?
We have not done any specific case study.
No,
on that.
I'm not telling any case study or anything. Do you know?
Yeah, but I can share you some. I mean,
I would be very happy to know. Okay.
Yes.
Thank
Yes, I
you.
can share you some data along
Okay,
this.
I think you can interact later date.
Yes, yes.
That would be good. Okay, I think thank you, Mr. Solomon, and let's move ahead. So we move on to our next speaker. I think after the material, we move on to our energy sustainability, and we have today with us Mr. Gautam Roy. Is a graduate in electrical engineering from B College in 1981. Is the executive director of CESC, Calcutta Electric Supply Corporation. And he's the chairman of a committee of Bengal Chamber of Commerce and Industries on sustainability. So who will be the better person than to talk on the subject when we are talking about the sustainability. So Mr. Gautam Roy, please. Gautam, are you there? Gautam, can you hear me?
Mr. Roy, we can't hear you.
Gautam,
Yes.
Okay.
Yeah, now we can hear.
Good evening and good morning.
Please keep your time of 15 minutes, please.
I will try, definitely. Good morning and good evening to everybody. 2020 is gone. It has really taught us how to manage uncertainties. We have so much discussed in the last few years how we will manage the disruptions, but when it really came into surface, we know how difficult it was. Same for sustainability. Sustainability, we are talking so much, but definitely it is affecting the climate. It is a great concern. And frankly speaking, sustainability is not today limited to the civic societies or academic fields. It is a boardroom topic also. In the Company Act, company law, this has incorporated. My point of saying is that energy is a key driver achieving the sustainability. And energy is no more an luxury or an option. It is basically entitlement. Now, since long we have been making a debate. It went back to Agenda 21 in 1987. Then 1992, we all know about the Rio Earth Summit, where the debate is on how to really lessen the energy consumption, but bring the efficiency more and more. And also the debate going on, who will contribute more, the developed countries or the third world countries? Definitely, there is a question of equity, there is a question of equitable distribution, that all these things come into picture. Nowadays, you will find that this has been converted into a major task discussion on COP, Conference of Parties. Actually, the COP discussion has started first in 1995 in Berlin. Then you all remember about the Kyoto Protocol, that was the third COP conference. Paris Conference of COP, which was a milestone, that has actually spoken of -2 degrees, bringing down the temperature to the pre-industrial era. And we all are waiting for attending 26th COP, which will be happening in Glasgow in November 21. So if we really now come to that debate, what I find on the technology aspect, if technology is considering as a box, we can see that the whole stress and the importance was given on the source management, source efficiency. I'm speaking on the generation, suppose. How really optimize, how really make the generation more and more efficient, and gradually you will find that from the Stoker fire boiler to PF boiler to supercritical technology, these all came into picture. Then it followed the transmission part. Continuously rising the voltage, then the DC transmission, then FACTS, the flexible AC transmission. And right at this moment, for last 15 years or so, the whole importance is given on the distribution and also to the last mile. Why? Because ultimate optimization lies there. And a unique component of the entire thing is becoming very, very important is the meter. Meter today is no more a measuring equipment. It is a management equipment. It is an information source, and people actually want to interact through meters. That's why the term called smart meters came into picture. That's why we are speaking of the smart grid. From my experience, I tell you, when I joined, I have seen all the hubs. I mean, almost 150 substations control the city of Calcutta. All were 24/7 manned, and it was basically a 3-shift operation. Today, believe me, none of the substations are operated through man. It is all remote controlled. And think about the communication technology, IT, which is playing a pivotal role. So it's a combination of technology which is coming into picture for managing the last mile as well as the optimizing the entire thing. At one point of time, the whole philosophy was governed by maximizing the process. I have seen people asking, how can you maximize your generation? But today the whole situation is optimizing, not maximizing. You have to schedule and plan accordingly to the need and what will be the schedule, what will be the demand projected by the consumer. So every day, a day ahead schedule is made into 96 time blocks, and that has to, as utility has to serve. Whole country is now operating 2 power exchanges on the continuous real-time basis, like the way the stock exchange is operating. So with the change what has happened in the last 1 or 2 decades in the sector of energy, on the question of reform, on the question of technology application, that is qualitative, phenomenal, if you can say disruptive, I don't mind. But whole point is India is definitely a great contributor. India started its journey in 1947 merely with 1362 megawatt capacity. Today, it is basically 374,000 megawatt capacity. India is the 4th largest grid in the world. From Dibrugarh to Dwarka, from Kashmir to Kanyakumari is one grid, and that brings the stability. I have seen the frequency hovering between 48 cycle to 52 cycle like anything. Today, I have not seen even it is, drifting for 0.1 cycle from 50 hertz. So that is the type of stability we have achieved by the time. But whole point is that India had made some commitment also. The commitment is that by 2022, it will be having 175,000 175 gigawatt capacity of renewable, 100 solar, 60 wind, and 15 others. And definitely, this is a solution. But I have intentionally, consciously raising a debate that the type of investment what has made in the last 2-3 decades all over the world on fossil fuel based electricity generation or energy generation, the most of the capacities are stranded today, idling today. What will happen? Because all of us know it's not a poor man's business. To add 1 megawatt capacity, it takes 10 crores of rupees. So whether the whole emphasis will be on the renewable and renewable only, or we have to really optimize and think properly to have a proportionate mix of better efficiency, I mean pollution clean energy from what we have invested also, like we are talking today on FGD, flue gas desulfurization plants, which again will call for an investment. There are some, if these are all hard options, there are some softer options also. All of us know, I am not speaking any innovations, but India being a vast country, whether we can take advantage of time zone. Time zone, why I'm speaking? Because if you see the demand of electricity or demand of energy is something which is not controlled by the utilities. It is controlled by the consumers. I do not know exactly when you will switch on your light at the house. It is completely at the discretion of the consumer. There are two types of discretely categorization of demands. One is clock related. We start office, we start school at a certain time, not looking into the light, but looking into the clock. Industry operates looking into the clock. So these are clock related demand. But there are a huge demand which is sunlight related. I do not switch on my light in the evening in my house looking into the clock. So if I can manage that part of the demand, which necessarily doesn't superimpose with the clock related demand, then I get an advantage. I get an advantage of peak chopping. Because the peak city of Calcutta, I tell you, the peak of the peak demand, it serves only for 20 hours in a year. Out of 8760 hours in a year, we only serve the peak of the peak in the 20 hours only. But I have to be ready with that capacity. I have to have that investment, because I cannot say that that part of the peak I will not be able to serve. And electricity, and this component, this product being a very unique, all of us know, we do not have any brand, we do not have any color like a car has, like other product has. We have only two components to compete. One is that the reliability, another is the cost. So now when we are talking about the renewable, are we sure about the reliability part? Reliability in a sense, the spikes, how we will be managing. So it cannot be a unidirectional solution. It has to be an hybrid. I was attending a seminar on UK seminar day before yesterday. Lot of scope about e-mobility. In fact, European countries have taken an oath. By 2030, they will be converting entire vehicular movement to the e-mobility. But the question is that chicken and the egg issue. The charging stations first or the car first? And there again, the question of hybrid solution, series hybrid or parallel hybrid. But it has to have a proper backup, because today people cannot sacrifice reliability. All sustainability issues we are speaking, but not sacrificing reliability by an inch. We are not ready to really pay more cost. This is a business which is a regulated business. We do not decide all over the world. No utility decides on their price in which they will sell the power. So, if we cannot have the issues in a comprehensive manner, in a manner from macro level to micro level, then probably the sustainability solution will not come into picture. Of course, storage is a solution. Storage is definitely an issue which has to be properly addressed to. Because if we can have the proper storage, that is again a unique issue. At every instant of time, we have to be ready to supply what is the demand, on which we do not have any control, because we can't store. So taking this into consideration, entire issue into consideration, I have few more points to say. Another important point I would say, that we are talking so much about the efficiency. Now, the producer itself consumes almost 8 to 9%, which we called auxiliary consumption. The transmission consumes 5%, which we call technical loss. The distribution, theoretically, India says that it is 22% loss. But in practice, we know 30, 35, 40, I have seen in my experience in the pockets of the country where the loss is even 70-75%. So think about, we are thinking something, we are doing a business on a product on which the 50% is gone. So the whole remunerative package has to be on the other 50%. And now if you consider truly the conversion efficiency of the equipments, what the end user is using, even if that is say 50%, then ultimate efficiency, ultimate energy, what is being produced and what is being ultimately utilized, what is the percentage it is coming at? Not even 30 to 40%. So think about the whole economy, macro economy, where it is lying. And it is a subject, energy, which we just cannot say that something, I mean, we can forget about. And peculiarly, suppose the e-mobility, we are speaking so much about the Tesla car, these charging stations, how to make it happen. But see, the whole, I mean, what we called in Bengali, the Mofosshol area, in the outskirts of the city, whole rickshaw thing has been converted into the battery-driven rickshaw pullers. No control economy, nothing is there. Convenience, the technology at doorstep. And you will find in many of the cases that those batteries are being charged from the hooking. So,
can you please wind up in a minute?
Yeah, I am almost finished. So now on the philosophical plane, why I am speaking, it is not a unique within boundary solution, sustainability. It is a cross-boundary, cross-country solution we have to come across, first of all. Second is the COVID has taught us how to become collaborative. So the collaboration is another very important, because the social cost of resource utilization, resource depletion is extremely important. And if we do not have the collaborative approach all over, it will be extremely difficult. Another very important, which organization to organization, large multinational corporations are also thinking on the circular economy. What we will plan, what the resource we will harness, we will plan, we will produce, we will deliver, service, but ultimately the waste, what will come again has to be recycled. So the business model has to be based on the circular economy. Otherwise, really, the sustainability we are speaking of, it will be little difficult to achieve, and we will not be able to achieve it without that integrated ecosystem, what I am basically suggesting. So it is maybe from the background of energy I am speaking of, I have mentioned some of the points, but it is nothing but what is my real life experience I am sharing and where we are. So with this, I think I have not shoot out the time. Thank you.
Thank you, Mr. Rai. Thank you very much. Quickly, we'll have one question before we move on to the next. Can you have? Is there any question?
Srimanda, this is Biman. May I have a question, please?
Yes, please. Yes.
Srimanda?
Please go ahead. Please ask.
Srimanda?
Please ask the question.
Oh, okay. Hello, Gautam. Good evening from Biman. Happy New Year to your family and you. Thank you very much for touching a very broad spectrum area. Just my question is based on your experience with journey with CESC from the last 37 years, where exactly you see that CESC made some landmark progresses in terms of the indices, in terms of sustainability, carbon footprint, reduction of losses, increasing efficiency, whatever. What are the key metrics that you are chasing and you have success story?
Just last, Biman, again, last sentence I could not listen.
No, I said, what are the key metrics in terms of improving energy efficiency that you have chased for the last 3 decades or so, and you have success story to share with us?
In fact, there are many parameters. As you know, CESC is uniquely placed. It is a basically integrated utility. Unlike There are generation utilities, large generation utilities, distribution utilities, but CSC is starting from mining, ending to last mile, everything is there. It is an integrated utility. Now, if you think about the generation, our generation efficiency with respect to the oil consumption, with respect to the auxiliary consumption, which are the indicators basically on the heat rate, these are all our generating stations are, listed in the top 5 power plant in the country. And it is not really, I am giving one example, our Bajbaj plant, which is 750 megawatt capacity plant. Of course, there has to be demand, because unless there is a demand, we cannot produce. But when there is a demand, there are consecutive years, Bajbaj plant has achieved 100% plant load factor on annualized basis. Having a 100% plant load factor on an annualized basis for a plant means 365 days into 24 hours, it has to run on the fullest capacity. So that type of level of efficiency we have operated. If we think about the transmission and distribution loss, our loss figure is hovering between 7 to 8%, which is one of the lowest in the country. If you think about the reliability part, the SAIFI, what we call the index on which actually we operate on the frequency of interruption and the restoration time. These are also one of the best in the country, if not the best. I'm speaking little with humbleness, I'm speaking, I should not say like this, but this is probably the best in the country. So these are some of the areas, be it on the distribution. In fact, we 10 to 12 years back, we had one full year, we have worked with Singapore Power. And Singapore Power is considered to be, even better in all parameters, the best in class world utility in distribution. And they measure interruptions on seconds actually. And what I found through because I anchored that project, what I found, it is not really the equipment. Even the Africa is using, or the whole world is using the same equipment, because equipment delivered by the MNCs. It is not the technology. Physics of engineering is also same. It is basically standard of procedures. It is the people and it is the processes. So unless we incorporate, we have been immensely benefited working with them. So these are some of the areas, I can share with you on bringing efficiency. Now our whole intention is to incorporate IT, IoT, and artificial intelligence, so that ultimately things can be managed more on a logic, not by the intervention of our whims and mercy of the people at large.
Thank you, Mr. Rai.
Thank you very, very much.
Any questions we'll take towards the end. I know that there will be many questions. I move on to the next program. We are going to have a panel discussion. We are really an interesting area. It's academia, R&D, and industry. In fact, we always keep talking about academia industry interactions. And I have heard many times from the industry persons, they say that, well, academic people are very high-nosed, we cannot approach them. Academic people say, well, industry people are not approachable, they don't listen to us. So there is always a conflict. But I always felt that, well, the three institutions, is academia, the research establishments, and the industry, they should come together to solve the national problems. We are going to have two panel discussions, in fact. The first one is on the prototyping and know-how transfer. And the panelists are Dr. Sugata Ghosh, who has done his PhD from School of Green Energy at IIST Shibpur. We have Dr. Chirasri Rai Chaudhuri, Associate Professor, who has done his graduation in Electronics and Telecommunications from IIST Shibpur, and presently she is the Associate Professor in the same place, and working in the area of electrical biosensors and related signal processing, with an aim to develop point-of-care diagnostic devices. She is the recipient of Young Engineer Award of INAE, Young Scientist Award from NASI, Institute of Smart Material Structures and Systems, and Women Excellence Award of DSTA CRB. She is also the Research Council member of CSIR, CSIO Chandigarh. We have the third panelist, Dr. Dipanjana Adak, in PhD in chemistry in 2013 from IIST Sirpur, and Mr. S.P. Bhattacharya, who graduated in 1978 in, again, electronics and telecommunications from BE College Sirpur. So we have the 4 panelists, and we have a total time of 30 minutes for this panel discussion. What I would suggest is that we'll go one by one, and I would request each panelist to talk for about 6 minutes, and then we'll have some time for some discussion. So we start with Dr. Sugata Ghosh to initiate the discussion on this panel.
Yeah, thank you, sir. Am I audible?
Yes, please.
Yeah.
Go ahead.
Obviously, a very good evening and good morning to the respected dignitaries present here. Today, the topic of the discussion is academia, R&D centers, and industry engagements, prototyping, and know-how transfer. Yes, I am not so much experienced, and I do not have some vast knowledge in this area, but I have seen both the industry and the institutions very closely, their work culture, motivations, objectives, and how they achieve their goals, etc. And when I have seen what I have seen, that is, there is a huge hell and heaven difference between the academic institutions and the industry. Fortunately, from the very beginning of my research career, in some area of my research topic, I was associated with a medium scale industry, industry house, that is MS Synchro Electronics, who are my industry partner. I have seen a big difference in approach of the academic institutions and industry. First of all, I will say the approach of an academic institutions. In an academic area, in an academic institution, scientists or professors are bounded mainly in terms of their research, number of papers, patents, number of PhD students, how many projects are ongoing for them, funding status, what is the funding, research grants, etc. And for these, they choose some hot topics and submit their proposals and obviously get the projects. And as a result of the outcome area is mainly in terms of few papers, patents, etc., and also PhD students. But a very few of the researchers think about a product or prototype. And we, the academicians, are happy with this only. But now the question is how many patents a researcher can sell in their life, or in most of the cases, perhaps not a single one, or maybe a few. And about prototype, how many of them are available in the commercial products as a commercial product in the market? Because we don't know what are the industry wants and what are the academics are doing. There is a huge gap between the academic and the industry. So whatever the prototypes are developed in the laboratory, that is only the conceptual and skeleton only. But in the industry, what they think about a new product, they think about the product should be reliable, repeatable, for and in their performance, even in some harsh environment. Normally, we in the laboratory we go for an ideal environment we create, and then we develop the product. But in what is the performance in the harsh environment? Mostly we do not think about that. Number two is the market scenario. What are the similar products available in the market? We should have to check first, and the demands, whether the products are at all demanding for the end users. And finally, it comes the cost, whether we can give it at low price from the available gadgets. And if we think that about a prototype, that the industry think obviously whether it is a profitable or not. If it is profitable, then how many units they can sell in a month or in a year. So these are the questions comes when an academic person goes to the industry persons for some prototyping and for some product related issues. And finally, what comes that is know-how transfer or knowledge transfer. It means that industry will acquire the knowledge from the academia, but when it will happen, or when that is only when they find that in a same research area the academic persons are working and also the industry is working, but there if there is a better approach and good result and attractive results for the researchers, then that in that case academic then that case the academic person can transfer their knowledge to the companies and to the industry. The industry will be interested only in that case. And for small scale industry, they always think twice before adapting any new technology in their business, because they need to calculate the profit and loss equations, because they are struggling day by day in their for their existence.
Please wind up in a minute.
Yes, sir. And for the large scale industries, what I can say that they have the ability to invest some amount, but whether they will, but they have also some R&D unit, and they can develop in their own R&D unit the same thing. So my question is, if we start to think for a academic and industry collaboration, and if we start to think that our product will come in the market in our daily life we will use, then only the possibility is if we start to work the academic institutions, the industries from the very beginning day, that is from the planning of the project, then only finally the product will be available in the market. Thank you, sir.
Thank you, Dr. Ghosh. Dr. Chirasri Rai Chaudhary.
Yes. So good evening and good morning to everyone. Thank you for inviting me in this panel discussion. It's a very pertinent topic because we as academic engineers. Yes, am I audible?
Yes, you are audible.
Yes.
Okay.
Please stick to your time of 6 minutes, please.
Okay, thank you. Yes, because we as academic engineers normally strive to develop products or prototypes that can ultimately benefit the common mass. But there are various challenges which Sugata has already pointed out, many of them. In academic institutions, when we submit projects, the research, most of the research is project funded, and only few of these projects are actually in collaboration with industries. Now, in what form of collaboration? There are certain project schemes of Government of India where industry participation is required right from the beginning. But what happens, even in such projects, in majority of the cases,
Dr. Rai Chaudhary, there is some
but
problem
not
with your
after
audio.
a thoughtful discussion with the partners.
Some problem with your audio.
Okay.
Unstoppable, even by our period.
Okay.
Menstrual health as part of our school curriculum.
Is it fine now?
Yeah, we can hear you. We can hear you.
Okay. So these projects are submitted. Definitely, we have the names of industries, the small scale industries, but at the end of the duration of the project, what turns out is either the say some part of the packaging, or some part of the PCB development, or in calibration, or in terms of some say for instance the some issues in the prototype development where industry partners do really collaborate. But that does not lead to the real know-how transfer, because after the end of the duration of the project, the investigators, since they're academicians, they get busy again with getting some other projects and pursuing the PhD of the students, getting more publications. Now that prototype which gets developed in the laboratory, to really translate that to society, there are various steps that are involved. Primarily, it needs a full-length product engineering, which will impart meaning to the entire prototype. Even in this step, a meaningful handshaking between the academicians and the industry is required, which we lack severely in most of the cases. The startup culture is really not very significant in eastern part of the country. And because of that, we lose the link with that industry who was involved in the project from the beginning. Because once a certain prototype is there, we show it to the funding agencies, they give some comments on the projects and we wrap up the story. This is typically what happens. But say for instance, the repeatability studies, the reliability studies, the reproducibility issues, they need to be solved by manufacturing certain amount of the prototypes repeatedly, doing field testing. For biological products, we need clinical assessments, and then the safety issues. All these things an academician alone cannot do. That has to be done in handshaking with industry. That part we normally lack. And also, why we lack? Because in our existing system, during the assessment of an academician, these steps are really not given due importance or due weightage. It is ultimately at the end of the day, the publications, the PhD students, the citations, impact factors, all these issues, they have more weightage. Because to really pursue the translation of the prototype into a meaningful product, one has to really devote a lot of time with the industry representatives, the product engineers over there, the process engineers over there, who will do the product optimization in terms of the cost of the raw materials, the consumables, the transportation cost, and everything. Then at the end of the day, the packaging issues, the aesthetics development, the ergonomics, the safety issues, all these steps have to be incorporated in that prototype to bring it from the lab to the common people. And for that, what we need is an integrated and collaborative hard work between the industries and the academician. So it's not just a case of one project. So it has to be a series of successive projects in various forms, which can actually take a prototype which was developed in the first phase of the project to a final shape, which can ultimately come to the benefit of the people. And that is where we really sincerely lack in majority of the cases. Where the students have a startup or where there is a collaboration with the startups, it really makes some meaningful visible products which comes to the society. But in most of the cases, there is a large gap which exists. Like there are very successful startups of IIT Bombay and various other IITs where they come up, if not for a large section of the society, but for the academic institutes, certain research level products which can be used at least in the laboratories by the undergraduate students or the postgraduate students. That also makes sense because most of these products even we import. So if some of the gadgets like a potentiostat, like a substitute of a kitlometer, if these sort of products can also be done and distributed to the academic institutes, that also makes a lot of sense. So there are certain areas which can really come out in the form of visible products by a true handshaking between the academic and the industries. But a system has to change a bit. The academic environment has to change to some extent to promote these sort of activities.
Thank you.
Yes.
Thank you, Dr. Rajiti. I think it's a good one. We move on to the third speaker, Dr. Dipanjana Adak.
Hello, I have just kept my video off because my internet connection is not good.
No problem. Please go ahead.
Just a small correction. I have completed my MSc in the year 2012 and I did my PhD in 2019 only.
Okay.
I'm very novice and I'm highly obliged and overwhelmed that I have been asked to, discuss these prototyping and knowledge transfer things. I am a research associate at CEGSS, IIEST. I'm working on mitigation of soiling of solar photovoltaic panel by developing functional coating with self-cleaning and anti-reflecting properties. For those who have no idea how this self-cleaning or easy to clean surface is related to the energy, photovoltaic and solar energy driven devices, I just want to introduce it very briefly. When scientists around the world are relentlessly working to improve the output power efficiency of solar panel with longer life and low cost design, soiling caused by this dust accumulation on the surface of photovoltaic module significantly reduces transparency over the time. And in turn, it results in loss of net output power of photovoltaic panel. According to a study made by NREL, it has been reported that this loss is somewhere between 40 to 70%, particularly in arid and semi-arid areas. Now, in order to achieve a sustainable power output, the surface of the solar glass cover are need to be functionalized with self-cleaning or easy to clean surface coating. Self-cleaning coating has some wide range of applications beside this energy and power generation sector, such as in biomedical applications, automotive industries, architectural glasses, textile industry, etc. And I'm very closely related to the product development process, which has some direct commercial impact. In all these sectors, there exists an immense pressure to develop competent product using some cost-effective and in a fixed time frame. The increasing demand is further adding to this competitive pressure. While a lot of research is targeting various aspects of knowledge and mechanism of increased learning in the product development, the reflective prototype can prove to be really beneficial for feedback at early stage of developments. The prototyping can basically reduce the gap between the professional knowledge which we are doing at our lab and we are gaining through our research activity and real world practices, enabling the researcher to developing the product that we are aiming for commercialization. So like our aim should be to develop a research, common research platform which include prototypes and the use and impact on knowledge acquisition and transfer with various product development organization and industries. Recently, I came across a video where the founder of a Indian-based startup company Log9 by Akshay, I think Singhal, who is also an IIT Roorkee alumni, developed an innovative aluminum air battery which is capable of running an electric vehicle at stretch for 300 kilometers, after which it needs to get refueled with simple water. And then after 1,000 kilometers of mileage, the aluminum plates are need to be rechanged, which is a completely emission-free electric vehicle. So it was very inspiring the way that it has functioned. Like he was a BTech from IIT Roorkee, and from there the whole concept of his startup incubated in IIT Roorkee and then shifted to Bangalore, and is working in such a fascinating way. This has inspired us, and as a researcher, I also want to follow his footsteps and footsteps of Solomon sir and everybody who are developing this startup and actually developing real life products for for serving the masses of our nation. That's it. Thank you.
Okay, thank you, Dr. Radha. Our next speaker is Mr. Sankari Prasan Bhattacharya, who graduated from BE College in the year 1978 in Electronics and Telecommunication. And I think Sakurida worked in HAL, right? Hindustan Aeronautics Limited.
Yes, I just to say one or two sentences. I retired from HAL as finally as the executive director of engineering and R&D. All the 10, 11 R&D centers were working under me, and I had a very good journey of 40 years of R&D. And as a defense, a lot of things do not come into. Just I was listening about the academics and this. Just one thing I want to mention here. We are the people who initiated the lot of IIT chairs in all the IITs with this. And one academic, what I initiated one project, the real-time operating system in development in India with ARINC 653 certification, which is and IIT, and we did that work part and IIT with Dr. Pallab Dasgupta and etc. They did the evaluation part, and we told that we will develop, and this is the only real-time operating system in the whole world which is certified by Semilac or that type of agency. Whatever others are there, those are all by company certified, their own company certified in the whole world.
Yes, yes.
So academy and this can do work, and we have worked. Yes, we have worked with a number of academic institutions. Yes, there is a chance of success, but this is one of our great success. And I was in academics. I was doing in IIT as an adjunct professor from 2014 to 2019 for avionics. So these are the things. In any way, I just want to bring some basic things in presentation. Can it? Sorry. I want to bring, and this presentation I want to bring. Is it available?
Yeah, it's visible. It's visible. But I would say that
Okay.
kindly please.
I know the time. Yeah, I know the time. First thing is this prototype, because I do not want to this theory, concepts and all these things. I just want directly what is happening in the R&D and what is the thing which is people are. There is a prototype concept is totally different. What academics and most of the R&D, most of the industry thinks the prototype is something is working. That is basically most of the time I see that engineering model is considered as the prototype, but actually concept proving of new technology, that is the first stage. Engineering model, here only integrated functions and operations are being done, but prototype is always a production standard. So gradually the confidence model is confidence level goes up when it comes to a prototype. But the moment prototype to production we go, the confidence level goes down to a very low, because production does not work the way prototype is handled. Prototype is handled like a newborn baby, but production they have something. And what we have seen that these are the things are required. Which is very much, at least there must be 3 prototypes to be built with different batch of manufacturing and bought out parts, because the tolerance, there are variations, there are a lot of things are there which would be used in the prototype. Otherwise, by one prototype everything perfect, and then when it goes to production it does not work. Similarly, test schedule to be prepared with judicious selection. Why? Now, the reason is that somewhere you have to do, like I am in the aeronautics, so I know that you are having safety, you are having bad environments, harsh operation conditions, and all this. Now, I will test, let's say, vibration on one unit, and acceleration on another unit, and fungus test on another unit. That will not, because ultimately the final stage, that is the only thing which is required, that all it. So test schedule in these 3 prototypes or number of prototypes. Reliability test should be carried out from a different batch of prototypes. First thing is this prototype should be where reliability test, yes, it works for all the environment, all the conditions everywhere. For that you need a different batch of prototypes, and that should go for thousands of hours of reliability testing. Prototypes to be subjected to worst condition, operational, environmental, and dynamic conditions. This is one of the things most of the time we miss, the dynamic conditions we miss. Most of the time we have seen, or my experience says, that in academics and in any other places, they do in a static condition, most of the tests are being done, and the wide variation of dynamic conditions are not considered. Similarly, where hardware software is integrated, there it has to be done 3-stage testing. Modular software should be integrated test, and software hardware. Other than that, failure, safety, security conditions to be generated. Most of the time we do not generate those conditions in the harsh manner. This is just a thing. You see that it is one of the most important thing in an operational in an aircraft, where it is an automatic flight. This is our own development, hardware, software, everything. I was heading the project. Now there are two computers, controls, all the so many sensors are near lower side is the actuators. Now this is the thing. Now here when you are making the prototype, it means it is hardware and software means. Now what will be the basic specification? There will be certain functional specifications like all these things, some physical specification like size, weight, everything, even cooling, how it will be, that should also be considered in a prototype. Similarly, software, what are the BSP driver softwares, how it will be, how the library functions you are testing, how the power on built-in test, what are the different applications. So now all things together and all things together will work in all variable conditions, then only a prototype testing means something. Otherwise, I am just doing and some functional work is going on and I am telling that my thing is working. And most of the unfortunate part of our country is this, that we do not understand that part. Apart from this, which are not written, there are certain performance challenges are there when you are doing the prototype. Timeliness, responsiveness, repeatability, fault tolerant, concurrent, predictability, correctness, robustness. These are the things when all these things will be just, we are just now, whatever we are listening or we have seen in my 40 years of work, that when somebody comes with a say that my prototype is working, that is only basically even not the engineering model in full. Some functions are working something, and there, that's why today what Saugata Ghosh was telling, that from academic or anything, they are these things or lot of things we are developing, but those are not converted into a product. Now, another, I just, you see that how everything is there in that hardware processor, hardware, everything to the production standard, and actually finally these things are to be flown, then only it will come. Similarly, this is another thing. These are the type of mission computers we have developed. We are, because of defense, we cannot put paper, we cannot do the things. Only last 2 years, 3 years back, we have got the thing that you can apply for patent. So all the things. So now you see, this is a unit, it is a prototype, and everything is, and so many hardware. And when we say hardware, it is not a hardware, it is includes BSP, drivers, everything. So first thing, this conception of prototype in this country, my experience is that prototype concept is very, very loosely understood.
Please wind up.
And another 1 or 2 minutes. Now another thing is the knowledge transfer. There are 3 things we are saying. To say know-how. What is know-how? Know-how means somebody will give and I will do a screwdriver technology. That will never sustain. And we have done a lot of things. This Biraj update program today, we are able to integrate the Israeli weapons, just because we always question why no, why we will do like this. So basically in our place also, that is a problem, that we think that know-how is the important, and we were very good at screwdriver technology and this. Second part is that from design to production, when we are transferring that knowledge, then also they just throw our design documents, because they cannot do like the designer, one unit, this side, they have to do mass scale. So production document, methodization, then manufacturing tolerance, then stage and module based schedule, so that several fault detection. So these type of things, as long as are not incorporated, a production drawings, which is from the designer to this, that is also. So this is my general view, that what I have seen, that what are our actually weaknesses, that we are thinking knowledge transfer means know-how, we are thinking prototype means engineering model. So the moment our industry as well as academics will come out of that concept, I think that we will be able to sustain. Thank you.
Thank you, Sankarita. I think we come to the end of this panel discussion. Quickly, Sankarita, can you stop sharing this?
I was doing that only. How to do that?
I think we will have a quick 1 or 2 questions before I really move on to the next panel discussion. Is there any comment or questions? Yes, Mr. Dev, please go ahead. Please unmute and go ahead. Yeah.
Okay. The problem over here is, I'll give some examples in United States, how it goes. Number one is, everybody knows about National Science Foundation. They are the main mover in science and technology research in the United States. There is one group is fundamental research and other groups applied research. In the applied research, I was fortunate to have the reviewer some time back projects. Their fundamental thing is you have to start from the idea, then engineering, and then prototype, and then production, all combined. When you go from idea to engineering, you have to tie up with the industry so that you can produce the prototype and then produce it, production stage. This is the whole package. Otherwise, you will not be able to do your research. This is one. The other one is, I was involved also in American Water Works Association, which is the association of all water systems of the country. And they have one organization called Water Research Foundation. This Water Research Foundation is funded by all the water utilities in the country. And these water utilities come up with the project that we have this problem, this should be solved. And they give it to Water Research Foundation. Water Research Foundation then gives the academic as well as consulting companies. They advertise and then you win the project. Once you win the project, you have to tie up with utilities along with you in the research. 2, 3, or 4 water utilities will be tied up with the research. And also you have to show in the research at the end, your application in the site. Therefore, the whole project, the whole composition is from research to the production and also using in the site. These are the things that we have to do. But in academic, there is one problem is publications. The professors are driven by publications and nothing else. And that's the problem, that they should tie up with the industry and so on. This linkage is missing and that should be restored. Well, I know that science department of Science and Technology in India, they support a lot of research and they should have this type of arrangement so that automatically it goes from one stage to the other stage. Thank you.
Thank you. Thank you very much. Thank you very much. Well, I think we'll move on to the next panel and then we'll have little time to have more discussions on different aspects. Our next panel is on the aspects on training and placements. And we have 2 of our alumni from BE College. One is Mr. Asim Dev. Asim, are you there? Hello. Asim is there. Okay. And Dr. Sivnath Maiti. Dr. Maiti, are you there?
Hello, I am here.
Okay, good.
My name is my Mrs. name, my phone, it is no. It is Dr. Maiti to be actually so Suparna Maiti. Okay, I'm here.
Okay, good. And I'm really happy that I know both the speakers, both Osimda and Sibnath. And I'm not going into the details as such. Osimda did his BTech BE from Bengal Engineering College in the year 1977 in electronics and telecommunication. And then he is associated with the industries in the IT sector for last 40 years. And Dr. Maiti is associate, I mean, he graduated in the year 1981 in the mining engineering, and he is in CMERI Durgapur as a chief scientist. So we have two speakers today who are associated with the activities on training and placements. So they'll be talking on the aspects on the training and placement. So I will start with Mr. Dev first, and I would request each panelist to talk for 5 minutes so that we can have little discussion time for the discussions. Osinda, please.
Thank you, Sriman. I'll not take even 5 minutes. I'll be very brief, okay? But I'll make one deviation because this program, can you hear me?
Yes, yes.
Okay. Because this program is on sustainability, I'll give a little brief of sustainability and what is my concern. Probably at the end, I'll ask a question also to the audience if they can respond. And then I'll go to training and placement. Overall, it will not take the exit time. See, I have worked in IT industry, okay? A big IT industries, okay? In IT industry, what is happening, the IT facility that you are giving to the CEO and to the person who has passed just now and joined the company, the facility is the same. So let's say big companies, 50,000 employees, 100,000 employees, you are giving a uniform infrastructure to the employees. Client wants you should have the latest technology, the best technology, but your problem is the budget. But anyway, you make a very huge investment. And after 4 years, that technology becomes obsolete. And in the 5th year, when you are approaching a new client, what is happening? The client will say, this is the technology you are using, which is obsolete, 5-year-old. So that means within a span of maybe 6 months, you have to just siphon out the entire technology, mostly hardwares. You have to invest again for so many people. What is happening in that process? The only big companies are surviving. There is no scope for small companies to survive and entertaining in that industry because those big industries will not encourage small timers. They will not encourage to buy anything from the small timers. That is a concern. What is happening? Earlier, we used to have lights from Chandanagar. Today, you are buying from China. So, because of sustainability issues, we are looking only for the big players. The China market is grabbing the India market and the small companies are, wiping out. My question is, if anyone can say that. Let me go to the next training and placement. I have seen training, okay. We had a workshop. I am electronics, but I had to go to the lathe machine and I had to work on gears and motors and pulleys. And when I joined IBM as a service engineer, I felt what is the necessity. Today, in terms of training, okay, it is absolutely insufficient. Absolutely. Probably the government institutes have a lot of limitations to implement, but private colleges are probably trying. So that aspect has to be addressed, but I don't know I don't have the answer. And in placement, the most important thing is just like when you are appearing for joint entrance examination, apart from your studies from what you are studying in the school, you have to go to FITG or some kind of institutes where you are learning, taking special coaching for 3 years, and then you are appearing for joint entrance and you are getting admission to colleges. This hope is not at all there. In what is happening is most of the students, they are not able to crack the interviews and other things only because they lack in communications, basic knowledges, basic knowledges outside book. That these two are the main concern. I don't have the answer because we are in a government institute, but these are the main concerns. Over. So two questions I've asked, that sustainability is killing the small players. And second is, I don't have the answer of this. Over.
Thank you. Thank you, Wasinda. Shivnath, please go ahead.
Could you hear me?
Yes, we can hear you.
Yeah. I don't know why I have been placed in this training and placement, because I don't know anything of this training and placement. I am a man of innovation, you can say. I have spent 30 years in research, 6 years in industry, mostly in CSIR, 30 years, and 2 years I was Controller General of Patents, Design and Trademark. I have my own 70 patents I applied in India, and I have 4 granted US patents, and in 157 countries I have patents. And in my life, I could develop 18 items out of my 70 patents, which I could market also. I could have shown something what the things we could do. But anyhow, I'm not an IT man. There are many scope in IT and softwares, people are saying, but there is a lot to be done in hardwares also, particularly in mechanical things. We have a lot of things to be done. Out of my 70 patents, 68 are mechanical, 2 are chemicals. Anyhow, had I been a chemical man, I could have done 600 patents. It's very easy to do in bio and biochemistry. Anyhow, the thing I was telling you, the first solar tree and the first, you can say, first electric three-wheeler made in India. I don't know how could handle this one. I could show just 1 to 3 pictures, but I have a lot of things here. Where I take at least 2 hours for all these things. It came in, in 2007-8, I made the first electric auto, and then the first solar electric auto, which is not yet in the market. And China came in 2015-16, and they are taking $1 billion only from this three-wheeler, electric three-wheeler, which is all coming from China. And the most pathetic thing is that when I go for lecturing to the students, I became from chief scientist to once I became director of CMERI, but anyhow, I could not go much ahead because I speak very hard things to the people, because India could have done a lot of things and still there is scope. Today, actually, many people spoke, but what is to be done for really future? Something tangible, like that Solomon. Solomon, has he made the battery? I wanted to know. Is it feasible, something tangible, something can he give me? This thing is, I can test it in my three-wheeler. Even today China is exporting all the things to us, but there is a lot of scope for the entrepreneurs, like small entrepreneurs. There is a lot of scope. I am telling you, we can do a havoc. I have many ideas on my table, at least 100. But thing is that people are, anyhow, I'm not getting the interested people who can do the things. And the future, suppose thermal, a very good innovations, there is scope for transmission and for transformer and other things. I don't know why not the power electronic transformer should have come by this time. Anyhow, but thing is that thermal has to be stopped. Thermal and oil, at least 80% coal, oil should be reduced. Raging should be reduced of coal and oil. That is must, the earth will finish within 20 years. But then what is the alternative? Is the renewable energy. But in what way? The solar tree was made by me first in 2005-6, and that is the best today. I could make 12.5 kilowatt solar tree, which is the biggest in the world, and the cheapest and the best design of the minimum material bill of materials. And it is staying for 12 years. When I went to the Ministry of Environment, showing that I am going to make a tree, they did not allow me 3 lakhs of rupees. They say, "Oh, to gir jayega." Maiti sahab, kya bana rahe hai aap? You are a crazy guy. The solar tree I have made, which is in Vizag, which stayed in this Amphan also. It is standing there with 32 panels and 12.4 kilowatt, and with the minimum structure. I have taken only 4 square feet of land for that. Anyhow, generally it should take 2,000 square feet. So many things I have to say with this for the students and for the innovators and for the, we have to come up, we have to, it's not that the small people cannot do, the small entrepreneurs, the young people cannot do, we at least 5-6 people, 2-3 people, 5-6 people, 10 people can come together and do the things. Particularly, my thing is that I am really feel we are unfortunate that Bengali people are not. Suppose Gujarati guys are coming up in such a way, but not like the Bengali people are bit. I mean, what did that say? Back foot player. We should come up, and but thing is that what is coming up? What is the future? Future, many things are future. Renewable energy. The future is solar, wind. There is no wind. There are no wind turbines. Wind turbines of 3 to 10 kilowatt will work, not that megawatt. There are megawatts, 1.5 to 2.5 megawatts turbines are there. Those are all failure, and that won't work. But there is scope for 3 to.
Shivnath, may I request you to just wind up in a minute?
Yeah, yeah. Sorry, Dada, Shivanda. So we have to. Say there are many things to say, many ideas with me that will work. One thing I can say, the future is solar, wind, and hydrogen. The young student, to my message to the young people is that for 3 you must concentrate on that, and hardwares of electronics. We do not know how to make an LED. People say me, Dr. Maiti, you are working with solar for a long time. How many companies are making? There are 600 companies. They are saying we are making solar panels, but it is a total blunt lie. It is blatant lie. We do not know how to make solar panel. We do not know how to make an LED. 130 crore people, we do not know what is an LED. I ask people, they will say me N junction, P junction, so many, the electron is jumping. But the beggars, nobody knows how it is made. It is everything, billions and billions and trillions of by trucks. It is coming from China. And it is same that we are making our festivals with the Chinese LEDs. I have been seeing LEDs for 50 years and asking the electronic people, what is it? They don't know. It is very painful for me to when I go to the students and to the people, and they anyhow there is a lot of scopes for us to do hardware. I don't know, even we are much behind the software also. Chinese apps are all over the world. I thought that our students are also, our boys are also very fast in, because our people in the Google CEO, but our people here in India, they cannot make even the apps. For the apps, we are depending on China. This is really same to us. Okay, I'll finish this.
Okay, Sidno, thank you so much. You have brought up so many aspects. Yes, maybe audience will be interested to ask a few questions. Well, I think
this is the first one. This three-wheeler, which is much better than the Chinese one, and this is the first. Can you see it? I couldn't manage my mobile. My laptop is not working. This is the first GAABESU. This is the first solar I made in 2008. But anyhow, even I spend my own money. My CSIR, my office, they are having crores of things for stochastics model, which will not give you result. If you give something tangible, there is a lot of questions. And if you make computer models, there is no questions. You will be granted crores of rupees. Doctor, I could have spent, I could have made, by my position, I could have enjoyed so many things. I could have, but if I go for tangible things, physical things, there are a lot of questions. ये गिर जाएगा, ये नहीं होगा, ये कैसे चलेगा, ये तो नहीं हो सकता है. So this is India. What can I do?
Okay, Dr. Maiti. Thank you. Well, I think it's a wonderful evening, and we had so much of discussions on several aspects. We started with Mr. Sarvajit Raksit, who spoke about open innovation, IP right, etc. Then we moved on to Mr. Solomon Jones, who spoke about material, graphene as a material, and then its future, and everybody agrees, yes, this is the material on which you need to work on. There was a talk from Mr. Gautam Ray on sustainability issues on the energy sector, and he spoke with the data that how relevant, what are the aspects that we need. We are talking about renewable energy sources, but then possibly hybrid is the order of the day. Then we had two panel discussions. The first one, we discussed about prototyping and know-how transfer, and we had three panelists, primarily from the academia, one from the industry. We had Dr. Sugata Ghosh, Dr. Chirasri Roy Chaudhary, and Dr. Dipanjana Adak, and Mr. Bhattacharya from the industry side. They gave their point of views, which are very relevant. And of course, there are a lot of questions, lot of debates on this aspect, and I think we can go on and on this issue for hours together. And the second panel, well, Mr. Deb have posed 2 questions for the audience. So I think people will try to address those issues. And Shivnath, yes, he has a lot of things to, so possibly it was little misfit in this group, but never mind, Shivnath, I think you have spoken your aspects, and there are, I guess, some youngs in the audience. They will ask some questions to you. Overall, I think it was quite satisfying, aspects on which we discussed. So I know that I have just taken precisely 2 hours. We started at 6, 8, and it is 8, 9 now. So nevertheless, I'm sure those who are here in this group, they will spend some more time. And let us spend about 5-10 minutes to have some kind of a discussion. And I would request, if there are any questions from the audience, please come up with the questions.
Mr. Chairman, sir.
Yes, Achyuta, please.
Yeah. After the first panel discussion, I raised my hand twice, but I could not.
Somehow I missed that. Doesn't matter. Please ask the question.
Would you permit me to throw something on the first panel?
Absolutely, absolutely.
Yes.
We are here to earn knowledge, so why not?
No, thank you, sir. Just few days back, I saw a lady from Africa. She has developed a bamboo frame for a cycle, and she has employed 33 people, and they are working, and it is working. Now, I am throwing a channel to my friend. I am 81 years today. I have done quite a few equipment machines in my lifetime. Okay, that apart, can they do further things? The wheel in Punjab, every day there is a newspaper comes out which says 12 paisa for this item. All cycle 1,000 elements are sold every day in the morning. Price is done. So we have all the elements of the cycle available in the market, element wise. Now I am throwing the challenge to my 4 panelists and to my audience that can you transfer a whole cycle, wheel particularly, which is costly part, from bamboo, from growable plants. I don't know how, I don't know the solution, but I am throwing the challenge. That will be a great work towards sustainability. The price of 4,000 rupees, 3,500 rupees of a cycle will come down, and India is the biggest producer of cycles in the world today. We will maintain that prime position. Thank you, sir.
Thank you, Achyuta. Any other views, comments, questions? I see one question from Varun Kumar Basak. Is he here, or I can ask on his behalf to Dr. Shivnath Maiti about how panels on a solar tree are routinely cleaned and maintained. Shivnath, could you hear my question? Can you unmute? You need to unmute yourself. Shivnath, you need to unmute.
Yeah. Can you hear me?
Yes, we can hear you. The question is that
see the picture. It is not getting bigger.
How panels on a solar tree are routinely cleaned and maintained.
Can you see the photograph?
Yes, we can.
You can see the photograph. You see this one. This is the big tree. You know, there is a. Just black and white is good one. Okay. Yeah. What I have done, there is a 1-inch tube from the bottom to the top. It has gone 1 meter up, and there is a sprinkler, inverted sprinkler over there. So when we start the knob here at the bottom, see water sprinkles all over the panels. There are say 30 panels. 30 panels go sprinkled, and only 5 minutes. Only if it is only for 5 to 10 minutes in the morning, then it is cleaned. And if it is done every day, it is perfectly cleaned. You don't worry about this one. Only in the rainy season, you don't need all that. Other times, only 10 minutes in a day. You have to on the pump and the whole thing will be sprinkled and it will automatically cleaned. But if it is, say, after 15 days, if it is, then it will be difficult because, then you need some pushing or something like cleaning with the brushing or something like that. But if you religiously do for 5-10 minutes every day, so there is no problem. And for at a stage, if the long trees are there, you can combine in only one valve can do the 100 valve trees also if it is in one line like that. There is overhead tank, water connection is there through that. Okay.
Dr. Maiti, the routine cleaning apart, you need to reach the panels for the contacts and also for periodic physical cleaning, and that has to be accessible.
Why physical cleaning?
Well, even you need to check the contacts. You reach the panels.
Why you need that contacts?
Well, you have a connection, you have a wiring, you have terminals there. You need to check, you need to access.
It is supposed to be checked. I don't think it is in 10 years. I have not checked. It is connection is there. Suppose if it is loose, if there will be indications at the bottom, which panel is disconnected. It is there. So all the wires.
You may have to replace also one of the panels.
You can reach there easily. What is the problem? It is 22 feet high.
How do you reach the place?
By a simple, say, this one. They are going. There is a. You see, in our cases we have welded L in the bodies of the tree. You can reach anywhere. But in case of general cases, we will suggest you take a sort of ladder like that, and you can reach there. No problem. Okay. But if you put the L's for your maintenance,
that can be done by motorized ladder.
Okay, that's all right. Any other?
We are doing with the bamboo ladder itself.
That's
for
fine.
23 feet, you need with the only bamboo ladder enough.
Okay. Any other questions or any comments?
Yeah.
Yes, please.
Yeah, this is.
Sriman, I have to make a move. I'll go. Okay, Sriman.
Okay, Asimda. All right.
Is Dr. Bhattacharya here from
Yes.
IIEST. Thank you, Dr. Maiti. I was in CSR NPL for many years, and I was in solar also, advisor to DST, and I'm in IST, Solar PV Hub. Congratulations for many of your ideas. Now about the solar tree, is that doable? Now, mostly it is becoming a demonstration project because, we have so much land, but yes.
It is the problem. Raghunath, we don't have land actually.
Dr. Maiti, hold on. Let him speak. Ask the question, then you.
Okay.
Yeah, we have also made TN installed, in selfie. Okay, this is a good idea, and I don't think cleaning, and there will be an annual maintenance or periodic maintenance for everything, and that can be. I don't think is a very viable idea, and thank you.
Let me tell you, in Pavagada, Karnataka, for 2,000 megawatt, they have taken 13,000 acres of the land from the farmers.
Yeah, I'm aware of all that.
Suppose for Bengal,
Dr. Maiti, just 1 second.
Please
let him complete his question, and then you please.
There is no land, Dada. That is a misconception that we have enough land for the for laying the panels.
Okay, I agree to you. I don't say that solar tree is not a good idea.
Not a solar tree. Solar tree is the only solution.
That is not the only.
Go for solar.
See, I'll tell you. Recently, I attended a talk by one American gentleman. Please you note down. His name is Dr. Rick Navarro. Dr. Rick Navarro is CEO of Renewable Energy Incorporated USA. Please search for it today. I had a talk with him. What he has done, let me tell this audience. I've given it to Dr. Arup Bhattacharya, the detail. I want him to talk.
Regarding what, please?
Dr. Maiti, please do not interrupt. Let him talk and then he'll come back. Please.
Dr. Rick Navarro, what he has done, anywhere there is a water, seashore or anywhere, he has devised a hydro power device which for 1 kilowatt to 100 megawatt, it can be deployed, and he has some patents to what he does. He raises the water with pumps and then creates so much pressure that it flows, and it has the energy, it is being sold everywhere. So with all, and we have done with solar thermal, solar desalination in Ramnathpuram. So all this shore area, and you know recently what happened in Kutch and all that, the hybrid type of thing. So yes, solar tree has its utility. And now coming to I saw your solar, you say Toto, what we call Toto here in Calcutta. This solar e-rickshaw is a good idea. And your concern that the motors and everything is being imported, I know. I'll tell you about it. There are many. We have a patent where we have one panel, 24 volt. If you come, Joydeep Jana, he is a startup. Please, I invite you to come and give a talk and our DST photovoltaic solar hub. Once I'm there, I'm in Bangalore these days, is open, I will invite you.
Okay.
You know Dr. Hiranmay Shah? You know Dr. Hiranmay Shah? So please, they are good ideas. So this, your Toto panel is okay. But if we can have the motor and every other thing, as you said, and you are in CMRI, I'm very happy with the director there. This is something we should stop import, and this is the right time. When there is, you see, Chinese are whole kit Chinese are giving. So if you can work on that, only one, all Toto by Indian motor and other hardware are not much.
Thank you, Bhattacharya sir. Please, okay. Thank you very much for the information that you have given. I will just take one more question from Pravida and then we'll close it. Pravida, please go ahead. You need to unmute.
My question is a very general one. It can be taken by any of the three presenters or people like Dr. Raghunath Bhattacharya. And that is the state of collaboration between institutes like IIST or IIT with industry. Has this been institutionalized? In other words, does every major institution have an incubator cell or a cell for easing this facilitation? I ask this question because my second alma mater was Imperial College London, and Imperial College was known for this collaboration between an academic institution and industry, which was very rare in England 60 years ago.
May I answer this?
Pravida, I can answer to your question.
Sure.
Yeah, it is like this at IIT Kharagpur. I know that we have a science and technology entrepreneurship part where we generate entrepreneurs, we incubate, and also we have a cell called Sponsored Research and Industrial Consultancy, where we have created a cell which we call Lab to Market. The faculty members who generate things in the laboratory, for taking it to the market, upscaling and other activities are being looked after by this cell, and it's being done. I would say though it's moderately in a moderate scale, it is being done, but this is happening, and I know in other institutes also this is happening in this country.
May I add to it? May I add to it? Hello?
Yes, please.
Yeah.
Yes.
So, Dr. Niyogi, you named me. You see, this hub we have in IIST is a unique, first of its kind. Let the audience know. Dr. Arup Bhattacharya knows. Solar DST IIST Solar PV Hub. Why this hub? When I was a consultant to DST, I generated this hub idea because Chirashri man, every other said that we do a project, give a report, take other project, deviating from that this hub has industry collaborator, a huge number. Come to our website and see it. I'll send you our website and you can go it. Now, this is a regular activity. Many of our projects with them, they use our thing. And so, and the IIT Delhi, as somebody is saying, Dr. Ram Gopal Rao and IIT Bombay are doing very well in this area. So this is not dormant. Government is active. We are also aware of that. And I assure you, we will make it work further.
Thank you. Thank you. Thank you so much for the information. And I think
Can I just add slightly? Just I want to add from industry point of view. What Pravirda is asking, I think that it has been institutionalized, as I have told. The world only our real-time operating system, we work together with a proper things. With IISc, with IIT, we have identified, like I'm telling you, when I was executive director, we have identified each IIT for, like Madras IIT, we have given a HL chair and made that they will be mainly for the engine items. Kharagpur IIT for the software and electronics. Bombay IIT will be what we have identified, and we know very well that we are having a very difference of phases. Phase difference is quite high, but we have to come. And I think that our initiatives from 2008-9, we have got a number of good outputs. As I am telling you one thing, and that is the only real-time operating system now flying in Hawk aircraft. It is a which is not Indian aircraft. We are flying it. One operating system flying on a mission computer in a Hawk. It met a lot of this. So institutionalized, but still a lot of channelization is required.
Long way to go.
As Orunda has correctly told, that institutions need a in between one development or that type of one thing, which is unfortunately not there. It is only.
This is not unique to India.
Thank you. I think we need
for
to.
the government of Canada, for the Department of Communications and Department of Industry, and this problem of how to move from ideas through research to commercialization is shared in many countries. I asked the question because I was curious as to what was the state in India.
I have just I just give me half a minute. I am just one thing. I appreciate what Mr. Niyogi has mentioned. Given a fact that Indian industries are quite contemporary, be it in automobile sector, be it in power sector, be it in telecom sector, the technology and the equipment, what we are practicing are almost, at par of the global standard. Now, for my clarification also, I would like to be enlightened that how much of these products, how much of these technologies are outcome of the research of the Indian research institutes, or how much really the final products are basically coming and dovetailed, and basically ultimately the final product is launched. So in my industry, yes, there have been some projects, collaborative projects with IIT Bombay, IIT Kharagpur, but at the same time, most of the things what we practice, which are absolutely of the global standard, but these are all ready to take type of technology, and we are using it.
I
But
think it
Gautam,
is
take
not
a very simple
the
example.
thing.
Do you use smart meters? And are those made in India?
These are made in India, but what I am trying to tell, these are made in India, but the technology what Secure Meter or Genesis, the meter manufacturers are using, are these the outcome of the research of the Indian research?
Okay.
That is my question.
Being from the academic institute, I can make one comment over here. I think both industry and the academia will have to open their mind and come together, because what happens is our Indian industries, many a time they say that, well, this our academia, Indian academia is not capable of doing that, but that's not true. I think we can demonstrate that yes, our people are also capable of doing it. But I think we need to work
100%
on.
I
Yes,
agree
there
with
is
you.
Absolutely correct. You are absolutely correct.
I 100% I agree.
You are absolutely correct. The type of modification and the field level innovations we do, if we can do, the academicians can do it 100 times better. That's not, and ultimately, though, in a worldwide, if you tell me, some of the research products is there. Some research laboratory has developed that. The technology what we are using. I mean,
I think that at least defense side, I can say that a lot of work are going on in the IISc and IITs, particularly the type of AESA radar, then a lot of fantastic hybridization. I just TK Bhattacharya in Torun Bhattacharya in IIT. He has done a lot of beautiful small, yes, the problem is this, that their priorities are so different from this that they cannot maintain time. Time is a factor, and if the time is being given to them properly, or they are having their priorities, how to go up.
I think
So that is the
problems are
problem.
there from both sides. This is what
But
I'm trying
academics today academics are fantastically understood the things, because these are not the old days concept of technology. Now concept of technology is different, and academics are very good. We have got a lot of benefits, but it is still, if you say how much percentage, probably 10%. Now it has started from, I think, after 2010 or so, 9, 10, this has started, the academics are, and I must say that one of the defense, that when we started with LCA projects in 80s, we were a very active partners, and that time we worked very closely with IIT Kanpur, IISc, and IIT Kharagpur, and they have come out with fantastic ideas and solutions. Yes, they could not give a product.
I think it is a kind of a thing that, we'll have to have denial. Then only we will be able to demonstrate that we work. Now it is being said by the government that you cannot import equipment, which is less than 200 crores worth of money, and then you need to fall back on your own thing. That's how possibly we learn
because
how
of that.
to use our
It is not because of that. We were 20 worked in pre-globalization, and after that we have seen always. So basically, I think that it is coming out, but it will take some more time. Particularly analysis and etc. They are doing
a wonderful, lively discussion. I'm sure you all agree. And 2.5 hours have passed. We possibly couldn't realize. And I must thank all of you for being here. And it's a great opportunity for me to interact with you and to see some of my seniors after a long time. I thank GAABESU for giving me this opportunity to conduct.
What happened? Your mute. It has been muted. Your voice is muted.
Sorry. I'm sorry. I said that it's a wonderful evening that we have spent today. I think 2.5 hours have passed, but we couldn't realize the time. And it was a wonderful discussion that we had. And I'm sure that we can keep on discussing these hours together. This is such a lively topic. And I must thank GAABESU for giving me this opportunity to interact with you and to see some of my seniors after a long time. And I'm sure that we'll have many more such occasions to interact. So I thank the organizers, and I request GAABESU to close the session.
Sriman, may I interject for 5 seconds? I'm echoing your voice. I thank you, Sriman. That this is a very lively session, and there's a variety of ideas participating. We would like to see how this kind of sessions covering very young and very old and experienced folks will share our ideas together and cross some of these boundaries that came up in the discussion. So thank you, Suman, for a wonderful hosting of this session.
Pleasure, my pleasure. Thank you.
Thank you, everybody. On behalf of GAABESU and ADI Associates, I would like to thank all the speakers and panelists. It is really a very, very enlightening, encouraging session we had today. And top of everybody, I would like to thank Sriman, the way he conducted the session, the way he kind of, kept to the timeline. So thank you so much. Thank you, everybody. Thank you all my seniors I see here. Thanks. Good night. Good night and good day.
Good night and good day.
Thank you, everybody. Thanks. It was a great event.
Thank you, everyone.
Thank you. Okay. Bye.
Bye-bye.
Rayan, you would do all the saving and close, okay?
Yeah, sure.
Thank you, Shriman.
Thank you. Thank you, Samantha.
You can stop. the
Shivanda, thank you. Special thanks, Tomake.
Oh, thank you.
Very well done, Suman.
So I'm ending the meeting.
Yes.
Okay, yeah. Good night.
Congratulations, Simon, and well done.
Thank you. Thank you, Pravida.